Throughout the Victorian era, multiple element tables were proposed that would systematize how these elements should be organized. Yet none beat the profound system of the periodic table of Mendeleev that would soon revolutionize chemistry. The initial periodic table of Mendeleev was built exceptionally that it even foreshadowed elements that were still undiscovered at his time. But there's more to that. Let's look at the modern periodic table. We all know that the periodic table is composed of periods and groups, but why is it that the periodic table is arranged this way? For us to understand this, we should first look at the building block of every element, an atom. An atom is made up of a neutron, proton, and electron. The proton tells the atomic number of an element, and these elements are arranged in the periodic table from left to right in an ascending manner of their atomic numbers. Now, I want you to look at the electron. Notice something? You see, electron moves in a particular way outside the nucleus of an atom. The shells, through which these electrons move in, hold a maximum number of electrons, which are 2, 8, 8, 18, 18, 32, and 32. But these numbers don't only tell us the maximum electron that each shell can hold. If you count each element on each period of the periodic table, you'll notice the same pattern. The shells, which also contain subshells, also have maximum electrons, and when the maximum electrons of the subshells are added together, they sum up to their corresponding shell. S has 2 maximum electron, P has 6, D has 10, and F has 14. If we're going to look for its relation to the arrangement of the periodic table, we'll notice that they are grouped in such a way that the number of columns of elements correspond to the number of valence electrons. So why is helium on the rightmost side and not together on the second group, together with the elements that have a valence shell of S? Well, helium is there because it's a noble gas. The periodic table grouped elements together that share similar properties in a block. The noble gas, for example, has its valence shell filled up completely with 8 electrons except helium. The chemical groups block are alkaline metal, alkaline earth metal, lanthanide, actinide, transition metal, post-transition metal, metalloids, nonmetal, halogen, and noble gas. As we've noticed, the left part of the periodic table is composed of metals that are separated by the metalloids from the nonmetals on the left side. This tells us that the metallic characteristic of an element decreases farther from the right and farther from the bottom. Not only that, the periodic table can help you predict other properties of an element based on its location in the periodic table, like the ionization energy and electronegativity. They increase as they move to the right and from top to bottom, while the atomic radius decrease as they move farther from the right and from bottom to top. So just when you think that Mendeleev's periodic table is arranged in a terrible manner, think again because there are more to it than meets the eye.